Hi students, today we are going to learn rational numbers. The video is meant for class 9th students and the chapter is the very first chapter in your mathematics book, which is number system. My name is Anshuman and we will finish this chapter number system in a few videos. This is the very first video today. So I hope you will like the video, you will learn from it, and in case you have questions and if you want to just share something, so I welcome you all to write in the comment box. So let us start. I believe that everyone here is aware of something like this: a line with arrows on the both sides. It is called a number line. As from the name it is very clear, it is a line. It has to do something with the number. So a number line has a 0 in the middle of it, and on the right hand side it increases in equal intervals, and we can jot down numbers over here on equal intervals. And on the left hand side it can decrease in equal interval, so -1, then -2, then -3, -4, and it will keep on going. So actually the number line has no end. It goes till infinity. Infinity is something which we can't count. It will keep on going, but for the convention, because we make number lines on your notebook, you draw it, so we will have a finite length. Okay, usually we use a ruler to make it. Now number line helps us learn wonderful things about numbers. The counting number, which starts from 1 till infinity, like 1, 2, 3, 4, these are called the counting numbers. These counting numbers are actually called the natural numbers, and it is denoted by n. So natural numbers are actually collection of all those numbers which are counting numbers. It starts with number 1 and it keeps on going. There is infinite number of natural numbers, so there is no end number. It starts with 1 but there is no end. Alright, then the second collection or the group is whole numbers. Whole numbers is just like counting numbers, but it includes 0. So 0, 1, 2, 3. So just like in natural numbers, if we include 0 in this, in the collection or in the group, then whatever we get, the collection is called the whole numbers. The symbol for whole number is W. Brilliant. Now, in the collection of whole numbers, if we include negative numbers as well, like we have included 0, then we have counting numbers. And then if we include the negative numbers as well, then it will be a even bigger collection. And this collection or group of numbers are called integers. All right? And integers are denoted by Z or Z. It is pronounced Z or Z. And finally, there is a bigger collection of number, bigger than the integers. These are called rational numbers. Now, these rational numbers include all these integers because it is bigger than integers, as I already mentioned. So it will include all these numbers 0, 1, 2, 3, 4 and goes till infinity, and negative numbers. Along with that, it also includes the numbers in between these numbers. So take any two number 0 and 1. So in between there is 0.5, 0.25, 0.10. So rational number includes all these numbers and even the negative parts of it. So for example, if we take 0.10 here, and this we call it as a rational number. So if we cancel the decimal here, just a moment. So if we cancel the decimal, then we have what I left with. So cancelling the decimal will give 2 zeros in the denominator. So after decimal, whatever digits are there, we put the same number of zeros. So this 0 and this 0 will be cancelled. So it is 1 by 10. So a number written in this form, like in a ratio, by definition we call it a number written in the form by P, in a form P by Q, where P and Q are nothing but integers. So P and Q are, small q, are integers. And there is a condition that Q should not be equal to 0, because we cannot divide anything by 0. So that's why then it will be undefined. So a rational number is a number in the form P by Q, and P and Q are integers where Q is not equal to 0. So P by Q, don't get stressed if you find something as P and Q, what are all these things are there. You can simply replace P and Q by integers. So what are integers? Integers are the whole number and negative numbers included. So for example, the example what we have taken here, 1 by 10. So 1 by 10. In this, 1 is an integer, as we can see, and 10 is also an integer. So if we replace P and Q by integers, and if Q is not equal to 0, whatever number we get, these are called rational numbers. Now, one very interesting thing about rational number is that if we write the rational number in a decimal form, so just take one number, suppose 2 by 5. If we write it in the form of a decimal, then we get 0.4, and that's it. Or 10 by 3. So here we will get 3.333, and there is no end of 3 coming back. So if we write a rational number in the decimal form, there are only two possibilities. One possibility is called terminating decimal, And the second possibility is called non-terminating repeating decimal. So either the decimal will be terminated, so 0.4, nothing after that, nothing is coming after that. So 2 by 5 can be written as 0.4. This is called terminating decimal form. And suppose if it is 10 by 3, so if you do the long division method, you will find it is something like 3.3333. It keeps on coming. Or we write it with this symbol 3.3 and there's a bar sign over it. So this form is called non-terminating. It is not terminating, it's coming back again and again and again. It's non-ending. The 3 will keep on coming. And it is also repeating. 3 is repeating, that's why it is non-terminating and repeating. Sometimes you will find something like this, 2.25, 25, 25. So what is happening here? It is non-terminating. Terminate means to finish, but it is not finishing here. It will keep on coming. And there is a repetition, 2.25, 25, 25 is the repetition. Alright, so a rational number can be written only in these two possibilities. That's it. So I think that's it. After that, we will do some questions from the exercise 1.1, and I hope you have liked the video. And the second video on this will be finding the rational number in between two rational numbers. So there will be two rational numbers given, and we have to find another rational number in between any two rational numbers. So it is not tricky, but there is a process. So we'll talk about it. Thank you.